So, I just quickly wrote this same thing from there. So, did you all get to read what I posted and with respect to what you have done, because I do not have to repeat whatever I have already put that, right. Did you get a chance? No. I had actually submitted as if I had attended the problem. Can you locate it at least, just see that in the with the assignment with some notes, guidelines on how it is solved, like that, some title I made and then post it in Moodle. At least just check whether it is readable or so, one of you at least. You are able to see, you saw my.
So all the rotary drivers will be concurrent, or like it depends upon the special case?
Yeah, it case to case it. See, first of all, rotary dryer, there are so many kinds of dryers, right. We would have seen if you go through. In fact, on this I recommend a book. If you can buy it, it is about 500 plus, in Amazon it is available. In our library there are some 20 copies, all dog-eared old ones is there. It is a very old book. It was kind of published during the 1960s, 70s, around that period. It is called Introduction to Chemical Engineering. There were two authors. One is called Badger, who is one of the big time chemical engineers, MIT those days, Badger, and Julius Banchero, he was an assistant professor. So, this book was called Badger and Banchero. Now it is stopped in print, I mean it comes as a special made to order, Amazon has it, it is about 500 odd books. It is a fantastic book. It like the title says, Introduction to Chemical Engineering, all basic principles of chemical engineering will be written. It is a book about 500 pages or so, lots of worked out examples covering both those days we used to call it as unit processes and unit operations, everything is available there. There lots of chapters on dryers. The beauty about that book is, apart from concept, because most of the text, like if you take Bird-Stewart Lightfoot is one of the books that you would have gone through, right, transport phenomena. So, it will be sort of the concept will be all in mathematical models, and this book will have that. It will also have some photographs of equipments which are already available in the market in those days in some detail, cut view and all that. So, it is worthwhile book for your career to buy it, 500 bucks is good, and especially if you go for interviews in chemical engineering companies, if you revise that, it is very helpful, because even though the book is 1960, the principles and the some of the basic equipment still continue to this day with some changes. It is a fantastic book. The connection to this rotary dryer question is that dryer chapter is very nice there. All sorts of dryers are there, tray dryers, spray dryers, flash dryers, fluid bed dryers, all kind. Rotary dryer is used in those applications where the material to be dried is a granular solid, so that it can flow. First requirement, the solid should flow. If it is a sticky fibrous material, very fine powder, it is a bit hard to use it in rotary dryer. The arrangement is, there is a cylinder which is slightly kept, when I say cylinder, the diameter is typically about 3.5 meters, big size, and about 20-22 meters long, big huge ones, and it is kind of slowly about 3 to 5 rpm it is rotating, and it is slightly inclined about 3 degrees with respect to horizontal. So, what would happen is, when it rotates, you can imagine the cross section of this dryer, there will be lots of stuff like this, small projections, and this is let us say rotating like in that direction. So, the solids will be like granular solids, and as it goes, some of these flights, they are called flights, small projections, they will take it, and like a curtain, it sort of as it goes up, it will fall like that, and the hot air is just passing through the diameter of this. So, there is some good nice contact between the falling particles and the hot air, and therefore, the mass transfer and heat transfer is efficient and it takes place. Beautifully the solid from this end to this end goes. Co-current current is, it depends on how nature of the solid. If the solid is rugged, meaning exposure to high temperature does not affect a bit, then what you can do, you can go for counter current, because in a counter current what happens is the coldest material is facing the hottest gas that is coming through that. So, when the coldest material is facing 300 400 temperature, if it still does not get affected in some way, you can go for counter current, otherwise you go for counter current. So, it is just by trial and error, people do physical experiments. If you put like this, what happens? If you put like, okay, you can't predict for a given solid what is the behavior. So, usually small pilot, in fact our chemical engineering lab used to have a small dryer. So, in a small thing you can make a small cylinder, put it in one way, put it other way and see what happens and so on. So, that is what decided. So, in this case it is taken as co-current I have shown, but for the problem it is not relevant. You can have any which way, because we are going to talk only about this gas, because this says in this is going out at 200 degrees centigrade. You could have had the flow differently, but as long as it is going out at 200 degrees centigrade, that is what the catch is. So, you got, is that to your neighbor? Did you get my, you are able to open and see? You are, is there. So, for you to read through that in time. So, with that, one of the thing I noticed is it is better to, when any situation, general rule is read that problem. The problem definition will not be 100% clear anyway. This is a reality of life. In textbooks, people actually make it so clear, so that you are able to solve the problem, because textbook is meant for teaching so many concepts. So, you should just go on. So, they make sure that it is simplified in such a manner, all the information that is available to solve the problem will be within that 4 or 5 sentences, or at least they will very clearly say, in case if you do not have this, please refer to such and such. Some guidelines also will be given. This kind of thing, if you go to this problem, is give some information, but it leaves a lot open for you. That is the first step that you have to accept. It will be like this going forward in your career. It will all be there, but it will not be brought together in a nice text and given to you, say to solve the problem. This point we are all agreed, that is the reality of life. You can't. The plus point is you can ask and you will be given that information, or you will be told where to go and collect that information. This is another important point for you to remember, for those of you who are thinking of a career in industry and company. This is the hardest part. Most of the people find their first job is terrible. I am sure you would agree with. First job is like this, because the environment here in a college and there is so drastic in that aspect. Here there is a syllabus, there is a time, there is a textbook, people are there to explain to you. There you are kind of drifting. So, it is very hard. I thought I made a mistake when I joined. I joined a very good company, by the way, and within the first month or so I said, okay, I made a mistake, I should have pursued. I got a lot of admissions from several universities, disaster, I should have come back. Luckily, usually most of the people work it out. It is a bit hard, but you get by. The advantage is, if you go prepared for that, which is what was not done during our time. There was no preparation at all. What it is a career in, we do no preparation. So, here I am trying to bring you some concept about how you can prepare. The point is, what was given is, there is some rotary dryer trying some solids, that gas is going at 200 degrees centigrade, it has got some SO2, it has got some particulate matter, it is going into chimney. Somebody comes and says, can you recover some heat on this, can you guys work on it, like that. That is all it says, no, nothing beyond that. Now, from there you have to assume that some information is there, some information is not there. If it is not there, you can do two things. You can make your own assumptions about the relevant information, state it, I made the assumptions like this, or you can ask, in order for me to take the next step, I need some extra information, can you help me? This you must learn from now onwards till the end of this course. Ask that. There is nothing wrong in asking, because in real life you will ask, and it is encouraged to ask. People say they immediately, your boss may not have that answer, but he will tell you where to go and collect that information. For example, in my write up I have said is that the first step any engineer does is, because he walks in, he is getting a problem by somebody which is only slightly unclear defined, go back and collect lot of information about that situation from the sources. For example, we will go and collect the process flow diagram, P&L diagram of that unit. It will be available, right? It is a running unit. So, we all said in a class that in a running unit there is lot of information available, historical data, everything is available. It may not be available on your table, but it is available somewhere in the company. So, you have to go and ask and study the existing, then all this will come, because from the text you might be wondering where did I get all this jumbo jumbo, because the thing said only rotary dryer 200 degrees 500 ppm SO2, that is it. Suddenly you are putting this, you are putting this, where is all coming from? It is all coming from, in my mind, the process flow diagram, everything is clear. In your mind it is not there, because you are not exposed to that. That is the thing that you have to go through and get. Then only you will know, come to the main problem is, this is only a glimpse. In actual life you will do a lot more. You will come back and say, okay, the problem is this got some heat content, this has to be recovered. Okay. Now, first question is, to what level can you recover the heat? Important question. First, I think what we should do is, it is coming at 200 all right, it is going into the chimney, to what level can we recover, and you have to quantify that number. So, two decisions will be, it depends on that it is available at 200 is a given, to what level can you cool it down is your choice, is not it? How do you decide to what level you can? Theoretically you can cool it down to any temperature you want if you have a coolant, but this is where you have to think, saying that if I cool it down, first of all I should transfer the heat to something which should also be in and around available. So, with this flow diagram then you will have a better idea. In fact, there is something about secondary air also is said there. So, the thing is, many people may say, what is this secondary, primary, tertiary, quaternary business? Air is air. Again, for a beginner this is a terminology. Not knowing the terminology is not a problem, you will never know terminology, but getting to know what it is the effort. So, then you would have count out, this is that hot air generator have given. Briefly, there is a fuel that is burnt, and in order to burn the fuel you require a certain amount of air. This, if you know the quantity of fuel Q dot in whatever units, meter cube per hour, kg per hour, we will be able to find out what is the primary R. Yes, can you find out? If I tell you Q is 100 kg per hour of some fuel, you have to define the fuel. I can't just say fuel, what fuel? In this case diesel. So, if I say 100 kg per hour of diesel, will you be able to find out the primary R required? Yes? Yeah, theoretical. At least a minimum, the idea is to burn the fuel, right. So, at least you must know what is the minimum quantity of air required, stoichiometry very clearly. The key assumption that we will make is air has got 20% oxygen, 80% weight, that is, or 2179 if you like. If you want to be very accurate, you want to do at the site one nitrogen analysis and find 18.7 and whatever you want to do. So, you will make one assumption. Second, you will assume the burner is such that it completely burns it to CO2, because if the fuel gets burnt to CO, you will require one kind of air, but then it is incomplete, you have not recovered the entire heat value from the fuel. So, you will know, using these two information you can find out the theoretical quantity of air, which only means that under given proper conditions, this is the absolute minimum quantity of air is required to burn the diesel into CO2 and H2O. Practical terms, manufacturers of equipments have found, because they are, somebody is making that burner, right, he has to put together a pump, spray nozzle, this, that, they would find that you would have to add some 10 to 15% extra air for that completion to take place. So, you will get some quantity of the primary air, but do not worry about that, because that calculation is not required for this purpose, but you will find that air quantity will, along with fuel burn, result in a hot product whose temperature can you calculate? I know the fuel quantity, primary air I am assuming 100% efficient, so 100 no excess air I get. What will be the resultant temperature of the mixture, can we find out? What is the principle we will use here? energy balance. Fuel, when it is completely burnt, it releases that heat of combustion, and that heat of combustion will go to raise the temperature of the flue gas from A temperature to B temperature. So, we will do some heat balance calculation and find what is that temperature. In jargon, industrial jargon, it is called flame temperature. You burn the fuel in stoichiometric quantity or slightly excess of that air. What is the maximum temperature you will reach of the combustion products is the flame temperature. Usually for the gases, this flame temperature is very high, in excess of 1000 Celsius, 1600, 1700 for example. Now, that air to handle and put it into dryer is a disaster, because it is very high temperature, and in order, even that furnace, if you go through the next step, you will find that the furnace has to be nicely insulated inside to protect the metal wall. Metals lose their strength at high temperature. So, this stuff which is the furnace is made out of some physical element, right, some steel plate and that. So, there will be internally, actually the next step you will understand is what is a furnace, which has got some insulation material and all that. So, this hot air will still be very hot, and the quantity of air, if you have calculated that quantity of air, will be moderate, it will not be very high. Now, switch to that rotary dryer. For the solid to get dried from this to this moisture level, you require some air to flow through. How to find out that air flow rate? Two things will happen. One, the air that is entering in should have sufficient energy to dry the solids and also heat the solids from this in the heat balance. Solids are also coming at some temperature, getting heated up to some other temperature. The moisture content in the solid is getting removed, that is why the solid is getting dried. So, these two will define the heat balance of the material. If you compare that heat balance with this, you should know that that heat is actually generated here, so that it can be transferred there, assuming 0 losses. This is only one part of that heat balance calculation, but life is always heat balance, mass balance and kinetics equivalent. Will it dry? If you just because you provide enough heat, theoretically speaking, will it dry means, of course, eventually over a period of time it will dry, but will it dry? What is the meaning is fast enough for the material, by the time it falls from here to here, it will get dried, means we are talking about mass transfer coefficients, right. If you know the mass transfer coefficient of the for that, then this amount of water which is to be evaporated in kg per hour, if you have the mass transfer coefficient in terms of kg per meter square per hour per degree Celsius, you will get that meter square equivalent, you get the point. So, for that experimentally it is found that you need a certain mass flow velocity through the dryer. Those falling particles and the air that is going through, they must have some relative velocity with each other. Then you can go to the funda as much as you want. Falling particle is taken as a, let us say, a spherical solid, there is a small gas film around that, then the mass transfer coefficient is kGA into partial pressure of the droplet or the surface, partial pressure of the water vapor and the bulk, that is the driving force, that is it. Excepting people do not do this on a case to case basis, take a differential element of the dryer DL, do this mass balance, integrate it, it is not done every time. Over a period of time, dryer manufacturers have got this done, and they would have found out the logic and told you, you must maintain so much of velocity and this temperature difference dries. Anyway, it is running dryer in this example. So, the background, if you go through that, you will know. Point is, I am coming to secondary air. So, after a fuel which is based on mass balance to dry the moisture, and therefore, what is the air that is required to burn, you will find that you have to add extra air simply because you want mass flow rate in the dryer. Incidentally, it will also bring down the hot air temperature. So, usually in this case it is not relevant, but usually it will be of the order of 350 to 400. So, which means that 1800 flame temperature, if it is brought down to 400, the amount of cold air you will add. Okay. Why this complicated description is, we are catching on the secondary air. Now, this word secondary air in the problem statement, now you can appreciate this is a lot of air. Let me conclude that way. So, you have identified a place where there is a lot of air and of course, it is cold air because it is just drawn. Why is it cold air? Because you want to bring down the hot air temperature to a moderate level. So, it is cold air. So, after all this we have touched our nose and say, aha, the secondary air makes sense here to transfer the heat from this. And of course, how much is the quantity of air I have to know. This actually the mass balance of the plant P and I diagram, flow diagram will have it specifically given you, but at least in this heuristic way we have first cut discussion we have to note this is worth working, this is probably second priority because you can make use of that heat for heating primary air also, is it not? But then the quantity is, we will figure it out that that quantity is small. So, it is not probably the best thing to do because this quantity by the way is sum of this plus water that is evaporated in the dryer, is not it? That part is clear. The quantity of air that is flowing past exhaust is a sum of this and air leakages if any plus the water that is evaporated, all of them are coming out. Therefore, if this is a large quantity, you should also find a fairly large quantity similarly cold available for which the heat has to be transferred. So, we have zeroed it on the initial. Why do not we think of finding out some secondary air actually makes sense, you must do that because many times boss or otherwise people can come out with a fancy idea which is probably not. Like a boss like me who comes and says, these wet solids, all this dryer air and all that is required. Instead use this hot air to dry the solid. I can come with that idea. If you think it is very stupid, you would not want to tell it on my face, but there are ideas like that going around, might be. So, as a chemical engineer, given a problem, go to the reality, do a basic check for yourself to see whether I am making, this is a very important step. In the first or second class I told no, gradually I find that the hollowing out of chemical engineering is happening in industry. This is the reality that is happening because nobody wants to go into details, and for a long period of time people have successfully remained in companies and organizations without going into detail because though you buy an equipment and set it up, it runs now, what is the problem here? Life goes on one way or other, there is market to worry about, there is this quarterly statement to worry about, life has been gone on, but very few people have gone in, and that is why when there is a crisis or a difficulty comes, everybody struggles. So, for you guys who are beginning your career, I want to tell you it is possible for having a very successful career, you will become one day CEOs of this company, I wish you, but take the path of strongest technical analysis because then you will be unshakable, your feet will be grounded on the earth. Okay. So, with that secondary air. So, this air now is available at what temperature? Room temperature. Room temperature, let us say we are not in Siberia. So, let us take 30 degrees. So, it is coming in at 30, this is going on to 200, now there is a possibility of heat exchange. So, that is what after all this 20 minutes of internal discussion you would have come down to. Somebody mentioned about pinch. I was a bit, in a way I was very happy to listen to this pinch, in a way I was not sure what he meant. Pinch technology is slightly very different. Pinch technology is for a network of heat exchangers. When you have, what is the meaning of network? There are lots of heat exchangers here, everywhere. Each one is having one stream which exchanges to another stream. So, every heat exchanger will have two streams, one stream transferring heat to the other stream which is picking up the heat. So, if they have n number of heat exchangers, you would theoretically have 2n streams going around. You have some configuration. Question is that the right configuration, optimal configuration? Analysis is heat exchanger network. In that, this so called pinch comes, which says you analyze the heat exchanger so that the process is pinched at one point of time, and that can be 5 degrees, 10 degrees, 20 degrees, whatever. For a single heat exchanger, the pinch does not arise. What it means probably is, shall I rub it off, or I need, is there a second page I can get on this? Should be. You have got some form of a heat exchanger. Let us put one, this is hot exhaust gas going at 200 degrees centigrade, quantity we do not know as of now. it is given in the problem, right. In problem it was given as 25,000. So, this is not true, this is available. Actually it was said Nm cube per hour. Now, we have identified one of them, which is the secondary air. You are now asking me why are you going for counter current or co-current. In this case air. So, there is no question of temperature, if sensitivity, and we know that counter current normally gives the better performance in terms of area, therefore counter current. So, this is combustion air, this is at 30 degrees centigrade. I can calculate, I mean not combustion air, secondary air. I would have back calculated equivalent to this x, this we have to derive, there is no other way, you have to go through this step, heat transfer mass transfer. But one can make some, here is where some intelligent quick judgments, because instead of doing it cannot be more than 25,000 meter cube. Can I make a statement like that? You will agree, right? Secondary air cannot be more than 25,000. Why? Because this is a sum of secondary air, primary air, water evaporated plus leakages in the system as may be. So, we can, I am now saying I am assuming 25,000 meter cube knowingly that it is high, probably it is lower, but 25,000. So, with that make a quick assumption. Next question is, we said this 200 should be brought down to what temperature? Go back to the fundamental question. Here now you should be able to give me an answer. What is the lowest temperature for which 200 can theoretically be reduced? You can answer only when this step is done, otherwise it is open ended, anything. I mean, what are you asking me? You can cool down the gases, anything you want. Here in this case, how much is the lowest temperature you can achieve? 30. You can't go below 30, right? In this system, if somebody says I will cool this to minus 15 degrees centigrade, you should say, when did you pass out, yaar? COVID batch hai kya? So, 30, but there has to be a driving force. Therefore, what we will saying is, let us say this gas, the lowest it can come out 45, 40, 38, whatever you want. I use a nice number of 45. The moment you decide this, you can decide this, not a great shakes. If you do this mCp delta T, and the same m we are assumed for this case, actually knowing that m is less, but you will get some. So, roughly if this drops temperature by 160, 160, no 155, 155, this will gain by 155 if the mass is the same. Clear? Quick rough calculation. So, this will be, if it is 155, 185, assuming no heat loss and stuff like that. Actually, this is not 25,000 meter cube, it is going to be lower. So, probably this will be of the order of 200, 210, whatever it is. So, rough understanding you have got about the heat exchanger, this. Now, step back and say, is it all right? Does it make sense first? 500 ppm SO2 is still sticking on our mind. Nowhere it says you must treat the gas so that before it reaches the chimney, it should be SO2 should be brought down. It is not explicitly stated in that thing. It is not right. You have to check it out in practice. Maybe there is a law which has just come last month, which says no gases going into the chimney should be less than that. That is an independent. Keep the back of the mind, because you can still treat the gas. This has got 500 ppm SO2, when it goes here you can still treat the gas, no. So, that is not relevant to this heat balance, but what is relevant is at 45 degrees centigrade we assume this gas is just non-condensable, but what that 25,000 meter cube had was primary air, which itself will have some moisture, 4-5% of air is moisture, which is why people Vayu and all that people are making, some fellow wants to cool air, atmospheric air and get water and serve humanity. Really, there is a machine lying in ICSR, you can come and have a look at that. So, anyway there is some 3 to 4% moisture in both air, but there is a lot of moisture is picked up from the solids. So, this material will have a lot of moisture. You will not know what it is unless you do the mass balance of the dryer, but you can figure out it is going to be quite wet. In that wet 500 ppm SO2, as it becomes cooler and cooler, there is a point where it will start condensing, that is the water and SO2 will start condensing, and this is a deadly corrosive material. So, normally unless you go for some fancy material of construction like chronifer, high nickel alloy and all that, people do not cool it down to 45 degrees. So, it is a bit of a cost benefit analysis. You can say, wait a minute, you have not heard about corrosion resistant material in life, is it? I will go for graphite heat exchangers, there are things are available today, what is the problem? You can, but that exchanger is definitely going to be a little more expensive. So, this is a bit of a trial and error business you have to go through. So, initially going by convention, normally people do not cool it down to less than 130, 140. Why? Because of the reasons I said. So, initially assume 130, then we will see why 130, why not 100 by superior material for 100. Then you will know this temperature will change. You can find out Q, which is because you know the mass flow rate, say specific heat, actual temperature drop, Q you know delta T log mean you can calculate, and you can calculate, estimate the kind of a size of the heat exchanger. This I give a lot of weightage for person to have gone through. This step is what I was looking for, because this shows you understand heat transfer, you are also able to work out some size of the heat exchanger. This is an important step. Otherwise what would happen is like this. I wanted to write IAS examination when I passed out. Sufficient care if it is taken in design a suitable heat exchanger of appropriate material of construction, and optimizing the heat recovery from the exhaust gases and finding out the place where the energy can be utilized, we can gain benefit to the organization in a cost effective manner, and of course whole thing being operated in a very safe manner. Did it mean anything? Or I meant a lot. Yeah. So, which means you will say, yeah, good English. Still the problem is, on the field your company is struggling whether I can recover that energy. It remains unattended, because someone has got to do this detailed exercise in an intelligent manner. Actually it does not require too much, it just requires a little bit of a, have I done some great thing here. It is just that I was used to doing it, I am sharing it with you. If you also get used to doing it, in no time at all you will be able to do that. So, that is the part of that exercise. So, you will get idea of the heat exchanger. 9:45, 9:50 we will close. Okay. Secondly, what you should do is that, why are we doing the size of the heat exchanger? I said it is critical, is because two things you will want before you go and make up your mind. How much money I saved, how much money I am spending. That is the whole purpose of this, right. By this scheme, how much money I will save, how much money I have to spend, does it equate to each other. How much money I will spend depends on the type of equipment that you are going to put additional, and heat exchanger will be one of the key equipment. So, that is this reason why this all this chakra going and finding out so many meters cube approximately of this material of construction heat exchanger is required. Life is not so simple there. When this passes through, today this gas is going to the chimney, this fan is taking to the chimney. Now, if you put this heat exchanger here and try to link it up there, will there not be a pressure drop? Because we have all been talking about this mass transfer has to happen, heat transfer has to happen, means there has to be a film shear across the film, and then only the heat and mass gets transferred. There will be a pressure drop. You can't have a system where there is heat transfer, but no pressure drop. So, there will be a pressure drop between this point and this point, that we will have to estimate. That depends on the size of the heat exchanger and the nature of the heat exchanger that you have done. It is a bit of a, here again the detailed calculations means you have to do some arrangement, take our handbooks, it is all fanning friction factor, all that in baffled with this and this sort of thing. So, pressure drop between the two you have to have some estimate, pressure drop between the two you have to have some estimate. Luckily, good news for most of you guys is, again you do not have to do this scratch. If you take chemical engineer's handbook, is it ever taught in BTech? There is something called chemical engineer's handbook, I have to tell you. Please try to invest in it and get it. It's a fabulous piece of for your lifetime investment. All that knowledge of previous generation of engineers, they are captured in the form of it's a misnomer. It's a fat book. It's not a handbook any longer. Buy it and keep it. It's very useful. Read it. There, usually it is said that based on a large number of survey of manufacturers, approximate expected pressure drop of heat exchangers of various types will be given. So, you can make it usually it will be a order of 75, 100, 125 millimeters of water column. That is about all the pressure drop that comes, because the logic being it should be pressure drop should be sufficient to get mass transfer, but at the same time low enough for energy loss is all known from historical times. So, people had worked it out and kept it there. So, with that, next question is you have to check whether this existing fan is in a position to handle this extra pressure drop. If so, you are lucky, you got away, no need of a new equipment. If not, you are stuck. You have to look at a new equipment. So, cost adds up. Same story for the secondary air fan also. It was just drawing from atmosphere, putting it into the furnace. Now, you are putting one heat exchanger into it. So, pressure drop you have to work it out. So, that is then how the gas from here to here gas has to go. Then Arundhati made a point very nicely. She talked about going to the plant, looking at the layout, and then oh, that is lying there and this is lying here, how do I bring it across? There is a duct and there is a support, and this has to be insulated, by the way, otherwise the heat will be lost in the duct itself. All this we have to add up, and remember that horrendous Excel sheet. Item number 1, land, in this case no land. Is building? No, in this case there is no building. Is there any equipment? Yes, probably a heat exchanger, a fan, and we find that when a fan is to be changed, can the motor be salvaged along with the fan? You have to do the calculation of horsepower, which is also written in my thing. If you do all this, you will get a rough idea about what is the investment, and what is the saving that you will get is very simple. MCP delta T for the configuration, you get the Q, convert it into equivalent diesel, you will get the value of the diesel, this versus this. It looks like that it is not too bad, that is the conclusion you will get. That is a fantastic conclusion. Of course, in real life people are not going to on that basis go ahead and then do changes. This idea will be taken, then more number of engineers in a much more detailed manner it will work, because everybody is now motivated. It looks like that there is going to be a good return on investment on this. The absolute numbers are not so very critical. You can make 5 lakh then either end, no problem, but it will appear 2 to 3 years payback period for this equipment, 1 to 2 years payback period for this. Payback period meaning how much money you spent, how much money you are saving. If it is coming 25 years, then people will talk, okay, with the optimization you may bring it down by. So, you get that feel of that, that is what is the purpose of that exercise. It is very interesting and exciting to do that. Okay. So, 9:50 I will stop for that. Actually, I am not very happy with this class. The reason is I thought I will use this class where you will ask, but I was finding 9:10, 9:15, 9:20 it went, then I said okay, otherwise. So, if at all we have a similar class as we go along assignment, do come and ask by yourself. I give it to you, you asked me a question about counter. Please ask that opportunity, because if you do not ask, I am afraid that this learning will not go into your mind. Like I said, this is not a course where you want to have credit in order to fulfill the academic requirement of so many credits you have to have. It is not that. In that case we can agree, we will give you the credit, no need for a class from tomorrow. You want it, you get it. IIT has it ever failed anybody? But I felt that probably based on the first statement which you all wrote, I want my career in 5 years, 10 years, I think you are serious. So, in which case you must go back and make use of this opportunities to come and say, wait a minute, I want to ask this, why is it not like that? Being first time, but I have to share, I am not very keen on again repeating lecture business in this kind of a interactive thing. So, come out with ask, your chance, you want to show, look, wait a minute, I can also do chemical engineering, no, what is the problem? I am really looking forward to that. Okay. Thank you. So, Monday we meet again and continue with our regular lectures on this.